Okay, I'm back, and now we're going to begin our introduction to geology by explaining what elements are found in the universe. And if you look in that first column, it shows you what are the main elements that you would find in outer space. So just looking at those numbers, those are percentages. What would you say is the two most important elements that you find in outer space? Okay, you can see that hydrogen is going to make up about 75% of the universe. Helium is going to make up 24% of the universe. And then all of those other elements in the periodic table only make up 1% of the universe. Well, this does make a certain amount of sense because if you recall, in our previous lesson, we said, how did the solar system begin? And we said it began as a big ball of gas, and that gas was hydrogen and helium with just about 1% dust. And that 1% dust is everything else that you see in that table. Okay, now let's look at what the Earth is made of. So again, look through those numbers in that third column there and find the most abundant elements found inside the Earth. Okay, and you will notice that the most abundant element is going to be iron at 35%, and then you got oxygen at 30, and then you got silicon at 15, and then it gets smaller after that. So I would want you to know, if you're one of my students taking the exam, is what are the two top elements found inside the Earth? And so that's going to be iron and oxygen. Now notice that in the Earth as a whole, it doesn't have very much hydrogen and helium. So what's going on here? So what do we know about hydrogen and helium? What do you know if you've got a party balloon that has helium in it and then you let it go? What happens to it? Well, it just goes off into outer space. So any hydrogen or helium that the Earth had just escaped into outer space because the Earth doesn't have enough gravity to hold it down. However, there are some planets in our solar system that does have enough gravity to be able to even hold on to hydrogen and helium. And what are those? So we learned last time that those were called the Jovian planets or the gas giants. So we'll get to them later. Okay, now let's look at the next column, which is what are the elements found inside the Earth's crust. So the very, very top layer of the Earth is called the Earth's crust. And it's going to be composed of different elements than what the Earth is as a whole. So again, I would like for you to know the two top elements that you find inside the Earth's crust. And so what are they? Okay, if you look, you can see oxygen's at 46, and then silicon is at 28. So do you notice that one of the elements that was very plentiful in the Earth as a whole is now greatly reduced? Which one is it? It's the iron. So do you notice that the iron is greatly reduced in the crust? So what happened to it? So what do we know about iron? If you have a chunk of iron in your hand, it's pretty heavy. It's very dense. So iron and the majority of the dense elements went to the core of the Earth. Do you know that there's more gold in the core of the Earth than there is in the crust of the Earth? It's just that we can't get at it. So all of those more dense elements went to the core of the Earth. So that's going to leave us with silicon and oxygen as our building blocks for minerals and rocks. And then I'd also like for you to take a look at the moon, and you'll notice that the moon is kind of in between the Earth's crust and the Earth as a whole. And this is a clue as to where did the moon come from. So we'll talk about that later when we talk about the terrestrial planets. But spoiler alert, it's going to form as a result of a collision. So an object hit the Earth, and then that material from that explosion then went into orbit and formed the moon. Okay, so here is a chart that again shows the periodic table of elements, but the most important elements that are found in the crust of the Earth have the white box around them. So keep in mind those ones that are off to the left-hand side. So you got sodium and potassium, magnesium, calcium, iron, and aluminum. So those are in very small quantities, but they're going to be very important in the formation of rocks and minerals. All right, let's take a break, and then when we come back, we're going to talk about minerals.